in statistics, in probability and statistics, we work with a type of variable that we call a random variable. So here's an example. So there's two scenarios here. First of all, in her book, Are You Normal?, Bernice Canner notes that about 7% of Americans say that they have flossed their teeth with their hair. Now, imagine an experiment in which 5 randomly selected Americans are each asked if he or she has ever flossed his or her teeth with his or her hair. So the outcomes of this experiment would be a collection of yes or no answers, right? So there's 5 people, you just randomly select 5 Americans, and you ask them, have you ever flossed your teeth with your hair? And what you're going to write down are yes or no's. And then another scenario. In this article, there's an article back in 2011 called The Information Diet, Come Hungry, Leave Happy. In that article, that notes that a survey of 70,000 songs that went from 0 seconds, or just above 0 seconds, to about 425 seconds. The average length of a song is 242 seconds, almost exactly 4 minutes. All right, so in this article, you've got 70,000 songs that they looked at, and they saw how long they're going to last, just above 0 seconds to 425 seconds, and on the average length with about 242 seconds, almost exactly 4 minutes. Now, imagine an experiment in which you just randomly select one of those 70,000 songs in the library, and you record its playing time. Right? You know its playing time. Now, the outcome of that experiment would be some number in this interval, right? 0 to 425. Right? So in the first experiment, the outcomes would be yes or no answers, and in this second one, the outcome would be a number between 0 and 425. So in both these experiments, we can represent the outcomes as numbers. Okay, I'm just going to read through this here. In both these experiments, this one and this one, we can represent the outcomes as numbers. Right? In the first one, that one right here, the yes or no's, we might ask a question such as, in a randomly selected group of 5 Americans, what is the probability that 4 or 5 of them have flossed their teeth with their hair? That is, what is the probability that in a collection of 5 yes and no outcomes, 4 or 5 of them are yeses? All right, so we're counting the number of yes outcomes. Even though the outcomes are yeses and nos, we're going to count the number of yeses or the number of nos, whichever you like. And that count can be any one of the numbers 0, 1, 2, 3, 4, 5, right? So these Americans that you're going to ask, so you're going to ask 5 randomly selected Americans if they've ever flossed their teeth with their hair. You're going to record yeses or nos. Well, how many yeses could you get? You could get 0 of them, or 1, or 2, or 3, or 4, or 5. Now, in the second experiment with the songs, the outcomes are already numbers, music play times, right? So these are music play times. So you might ask this question: what is the probability that a randomly selected song is between 150 and 200 seconds? So we're representing outcomes of an experiment with numbers. So some experiments, such as these two, have outcomes that are due to chance. Therefore, outcomes can vary. Right now, both of these are due to chance. Right, you're going to get 0 or 1 or 2 or 3 or 4 or 5 yeses completely due to chance, and the song length, that's going to be completely due to chance too, because there's it could be any one of those 70,000 songs. Now, so one group of 5 people may produce different yes and no responses than another group of 5 people. The length of one randomly selected song may differ from the length of another. So the outcomes of both experiments are subject to chance because the items sampled are selected at random. So now let's make a definition. To answer a question that involves outcomes that are subject to chance, we introduce a random variable. So we're going to define a random variable. Let's read it, and then we'll talk about what it means. A random variable is a numerical description of the outcome of an experiment. So the outcomes of the experiment are subject to variations that are due to chance. A random variable is commonly represented by a capital letter x as opposed to a lowercase x. So what we're saying is that a random variable is a numerical description of the outcome of an experiment. Now, in this first experiment, we had yes or no answers, but what we did is we decided to count the number of yes or no answers. So we're going to describe with numbers the outcomes of that experiment. In the second example, the outcomes were already numbers, right? Because it was just the time, the length of time a song plays. So like in example 2, in the first experiment, the possible values of x, the random variable x, are the numbers in the set 0, 1, 2, 3, 4, 5, the numbers of possible yes answers to the question, have you ever flossed your teeth with your hair? So x is a random variable because its value results from an experiment with outcomes that can vary from one experiment to another experiment. The number of yes answers can vary from one experiment to another due to chance. And in the second experiment, the possible values of x are infinitely many numbers in this interval 0 to 425. The numbers represent the time length of a song, and x is a random variable because its value, the length of a randomly selected song, results from an experiment with outcomes that can vary from experiment to experiment, right? The length of songs can vary from one choice of a song to another. Now, there are different types of random variables. There are discrete random variables and there's continuous. All right, so here's what they are. A discrete random variable is one that assumes only a countable number of distinct values. Discrete random variables are most often counts. All right, so if you're counting something, that's going to be a discrete random variable. So the random variable in that first experiment is discrete as it can assume only one or more of the 6 numbers, right? So that x will be discrete because it can only assume a countable number of values. It can only be 0, 1, 2, 3, 4, 5. It can only be one of those 6 numbers. The number of possible values for the random variable is countable. Now, a continuous random variable, that's one that can assume an infinite number of possible values. Continuous random variables are most often measurements. So if you're counting something, you're probably dealing with a discrete random variable. If you're measuring something like time, weight, height, whatever, that's going to be continuous. So the random variable of our second experiment, that's continuous because it can assume any of the infinite number values in this interval right here, 0 to 425 seconds. So the measured length in seconds of a randomly chosen song might be somewhere in this interval right here, right? It could be right in there. There are infinitely many numbers in that interval. So discrete, a random variable is going to be discrete. If you're counting, it's going to be, if you're measuring, it's going to be continuous. So I've written 5 examples here. What we're going to do is just classify each one of these random variables as being discrete or continuous. Now remember, discrete is going to be something that we count, and continuous is going to be something that we measure. All right, so just think, are we counting or are we measuring? So number 1, the number of cars in a college's parking lot. Okay, so are we measuring or are we counting? I think we're counting, so this is going to be discrete. And number 2, well, number 2 is up here. All right, so the weight of a basket of berries. So are we counting or are we measuring? Well, I think we're measuring here, so I'm going to say this is continuous. And the third one, the volume. As soon as I see volume, I know I'm measuring something. So it's the volume of a randomly selected onion. So I'm going to say that's continuous. And 4, the length of time. All right, the length of time. Now, time's continuous, we believe, so I'm going to say that's continuous. And number 5, over here at the bottom left, the number of, okay, as soon as I see the number, I know I'm counting. The number of pages in an economics textbook. All right, so this is going to be discrete.